let's discuss where f is discontinuous, what kind of discontinuity it is, and whether f is continuous from the left, right, or neither. So let's think about the different kinds of discontinuities that we have. We can have a removable discontinuity, where the function may not be defined, or may be defined, but at a point that's different from the limit. There is also a jump discontinuity, where the function sort of jumps from one value to another. There's also an infinite discontinuity, where there's a vertical asymptote, which can be like this, or also another way like this, or something like that. That would be an infinite discontinuity. So now let's look at our graph of f. So let's start from the left to right. So we see that at x is equal to -4, f is not defined. So that means we have a removable discontinuity at x is equal to 4. -4, I mean. At x is equal to -2, we have a jump discontinuity, just like we saw earlier in our picture over here. So we know that f is discontinuous at x is equal to -2. At x is equal to 0, it's actually continuous, because let's think about the definition of discontinuous again, or continuous. The definition of being continuous is that the limit as x approaches a of f of x is equal to f of a. Or in other words, the left and right hand limits agree, and both of them are equal to f of a. And we can see at x is equal to 0, even though the function has a sharp corner in it, it's still continuous, even though it's not differentiable, but that's not the topic of this video. So now let's look at x is equal to 2. We can see that we have another jump discontinuity. And at x is equal to 4, we can see that we have a vertical asymptote. So we have an infinite discontinuity. Let me just erase this. So now we've identified where our function is discontinuous. We've identified what kind of discontinuity it is. Now let's think about whether it's continuous from the right, left, or neither at these points. So let's remember the definition of continuous from the left. That means x as x approaches a from the left, f of x is equal to f of a. And continuous from the right is that the limit as x approaches a from the right of f of x is equal to f of a. When we look at our first value, x is equal to -4, we see that f of a is not defined. So it can't have a left or right hand limit. So at x is equal to -4, it's neither continuous from the left nor from the right. Now let's look at x is equal to -2. We have a jump discontinuity as we discussed earlier. But we see that the value of the function is over here, and we need the limit from the left hand side or the right hand side to be equal to this value. And the only place where that happens is from the left hand side. So -2, at x is equal to -2, the function is continuous from the left but not the right. Now let's look at x is equal to 2. This is another jump discontinuity. And for similar reasons that we had at x is equal to -2, we need that the function be, that the limit of the function from the left-hand side or the right-hand side be equal to this value over here. But that only happens on the right-hand side. On the left-hand side, we can see that the limit approaches this value over here. But that's not equal to f of a. F of 2, where a is 2, is equal to this value over here. So we have that at x is equal to 2, the function is continuous from the right-hand side only. Finally, for similar reasons, we have that at x is equal to 4, it's continuous from the right-hand side. Because f of 4 is equal to this value over here. And the limit from the left-hand side is negative infinity. But the limit from the right-hand side is this value over here. So it's only continuous from the right-hand side. And that's it.